8.4 is about formulas and further applications of quadratic equations. So what we're going to do in this section is we're going to solve formulas involving squares and square roots for specified variables. We're going to solve applied problems using the Pythagorean theorem, and we're going to solve applied problems using area formulas. When I say applied, you know I mean word problems. And then we're going to solve applied problems using quadratic functions as models. So lots of good examples in this section. So first thing I want to do is solve for the specific variable. I want to solve a equals pi r squared for r. So I'm going to go ahead and try and isolate that variable. This is variable manipulation. We started doing this back in chapter 1 and 2. So I'm going to go ahead first and divide both sides by pi. So I get a over pi is r squared. And then I need to go ahead and take the square root of both sides. And remember, when I take the square root of both sides, I have to take both the positive and negative square root. So I find that r is plus or minus the square root of a over pi. And typically, maybe we'd want to rewrite this so that r is on the left-hand side, the variable we solved for, but that's not 100% necessary. Oh, but wait. Okay, if I have this, a over pi, that's the same as r equals plus or minus the square root of a over the square root of pi, right? If I distribute that square root. And do we like radicals in our denominator? No, we have to rationalize. So we're going to multiply on the top and bottom by the square root of pi. So I find r is plus or minus the square root of a pi over pi. Again, key step, we have to rationalize all denominators. We know better. I know better. Next, we're going to solve s equals 30 square root of a over p for a. So I'm going to go ahead and divide both sides by 30. I have s over 30 is the square root of a over p. Well, what does square roots? It's going to be squares, so we have to square both sides. I get s squared over 30 squared, which is 900, is a over p. And then in order to get a all by itself, I multiply both sides by p. So I get ps squared, because we prefer things alphabetical, over 900 equals a. Let's solve a quadratic equation for a specific variable. So I want to solve 2t squared minus 5t plus k equals 0. Okay, now this is a quadratic, but I've got this k. I don't know what k is, and I'm not supposed to solve for k. I'm supposed to solve for t. So for this, we're going to use the quadratic formula by letting a equal 2, b equal negative 5, and c equals k. So I have t equals negative b, so that's negative 5, plus or minus the square root of b squared minus 4 times a, which is 2, times c, which is k, all over 2a. So it's 2 times 2. So t is 5 plus or minus the square root of 25 minus 8k over 4. So that's all I can do. I've solved for t, and I can't simplify this any further. So this is actually our final answer. Next, let's go ahead and solve some problems using the Pythagorean theorem. We love the Pythagorean theorem. So friendly reminder, the Pythagorean theorem for right triangles is a squared plus b squared equals c squared, where c squared is the hypotenuse, otherwise known as the long side. So let's say a ladder is leaning against a house. This is the closest thing to a house I could find, a house. The distance from the bottom of the ladder to the house is 5 feet. Cool. The distance from the top of the ladder to the ground is 1 foot less than the length of the ladder. So let's let x be the length of the ladder, and the distance from the top of the ladder to the ground is going to be 1 foot less, so x minus 1. So now I can substitute this into the quadratic formula. So let's let this equal a, b, c. So I have 5 squared plus x minus 1 squared, remember we have to FOIL that, equals x squared. So I have 5 squared plus this FOILed, right? We can't just distribute that squared. It'd be so nice if we could. So I have 5 squared plus x squared minus 2x plus 1 is x squared. I guess I could have written that as 25. 5 squared is 25. I combine like terms, so I have x squared minus 2x plus 26 is x squared. Subtract x squared from both sides. I have negative 2x plus 26 is 0. I hope you see now this is just a linear equation, which is nice to solve. 2x equals a negative 26. Divide both sides by negative 2. X equals 13. So the length of the ladder is 13 feet, and the height from the top of the ladder to the ground would be 12 feet.